Alright, these curly braces in C++ are what's referred to as a scope. Now, you usually see them commonly associated with functions, but what they mean, because you can put these anywhere. I mean, you can just put them, you know, like out in the middle of nowhere for no good reason. Now, any variable you define inside this scope, like x, is only going to be valid inside that scope between these two braces. Okay, it comes out of this scope, x ceases to exist. It's almost like you're calling a function. So that's just something to keep in mind about C++ programming. Now you can see a function, like we have here. These are called for declarations. And this is using namespace standard. That's because you don't want to have to put std colon, which is a scope resolution operator, in front of a lot of these commands that you'll see down here, like cout. Now, most of the commands, a lot of the functions are actually built into C++. Certainly, multiplication, division, etc. The Boolean operations, for bit manipulation, bit shifting, all that. That's all part of the C language itself. And as are, classes and structs and enums, and a lot of these other things now. But there are, functions and libraries, that have to be added. And let's see, return is a function in the C library. See if we can find any here. This is pure C right there. Cout. Cout is a great example of a function that's part of a library. It's in the the IOStream library, I believe. Now this IOStream library, for the most part, when you're doing Windows programming, you'll never touch it. It's really only for consoles. And strings too, or you can use them in Windows programs, but generally Microsoft has like newer strings that they use, which apparently have some better functionality. But when it comes to these for declarations here, these are for functions that we call later in the program. Now normally something like this goes in a header file, and ignore this. This is not something I created. I don't know where these came from. It's part of the the pre-compiled program that this thing creates when you create the console application, unless you select a blank project, which I didn't. But these are a common set for console applications. These are a common set of functions, that I'll put, in every application except for maybe vector. But at any rate, you have all these for declarations because later in the program, I have the functions defined at the end of the program code. So, but C compilers are stupid and they get confused, if you don't put like declarations and shit all over the place. So, and these things here actually can create problems too. These includes, so because you can create circular dependencies, and so I mean, it can get complicated. That's something I've still yet to master. So hadn't run into it yet as a problem, but I'm sure I will. Now, right here you see something called an inline function. Now the only real purpose of putting this, because like I said, we can eliminate it and the compiler won't have a problem with it. But the only reason you put it in there really is just to tell other programmers and yourself that are, I guess, naive, and that, hey, this is the entirety of this function between the scope resolution operator here. But other than that, you don't really have to do that. And any C programmer that knows half the shit how to program in C, in other words, somebody that's messing with your program should have a fucking clue about how to program in C. Otherwise, they have no business tinkering with it. So again, really, I wouldn't bother with that personally. But on the other hand, I'd write my function differently than this too. so it's more apparent. I wouldn't put it all on a single line like this. But the books I read, made some kind of big deal about it. But really, I mean, in a header file or whatever, a header file is no different than a CPP file. You can put anything in there you want, and you can call this just a .c file too. But anyway, you can put anything in a header file you want, including your entire program if you want. I mean, it does not have to have a CPP file or a .h file, but it has to have one or the other. But at any rate, you don't really need to declare that as an inline, but that's just a keyword that you can use if you want to. Now, another little command you can use here, and this is really involving Visual Studio, to use the peak definition command, or right menu function or whatnot. And that shows you, where the function is defined and what it is, and this kind of comes in handy. So it comes in real handy because you can actually not just look at your own code, but actually look at the code in these files, when it pertains to it. So let's see, as an example, I can go peak definition on cout. Okay, and that gives you, this next level in the IOStream library where it is. Now, if there's anything in here that you don't understand, like this, I can go peak definition into that too, and that, takes us to this file here. So you can just keep doing that, again and again and again if you want, and it'll, take you deeper into the rabbit hole. You can even go to definition if you want to, or go to the declaration. So, you got that kind of capability, which is pretty cool. So, and this right here, shows you how deep in the stack you are. So you back up through that if you want. Let's see. Now, the reason I'm making these videos is really just to, in case I go away from C for a while and forget all about it, I want to be able to come back to this and try to remind myself without just having to review code that I wrote who knows how many years ago. Now, this function here, of course, is a recursive function for a factorial, which is, kind of a bit of a waste of time. But what happens is this thing, basically calls itself over and over and over again. Accepts an integer as input, but if n is basically equal to 1, okay, it just returns 1. If it's not equal to 1, it calls itself again. So that's what they call the ternary operator. Okay, but basically it'll keep telescoping out. Like if you send it number 10, well, first pass through, it'll go, okay, I'm going to pass 9 to myself in the future, and then 8, then 7, then 6, and 5, and then it finally equals 1, then it starts returning, and that's when it does the calculations. Okay, so it's 1 times n, and it'll return that, and then it'll return that as n, itself, and multiply it times n, and then so on until it comes out of that loop. So, but recursive functions generally are frowned upon in programming, mostly because they're hard to debug, really, and then they're hard to follow too. So I mean, they're not really good. It's not really good etiquette. When it comes to programming, not really a good form, which is good because they confuse the shit out of me. But this program is understandable, but if you follow it, but there are others that aren't. But the thing about recursive functions is that there's some problems that you can almost only solve that way. So I can see the value, it's just hard to wrap your head around them. So I wish there was some way I could diagram some of them, because I've seen functions that call themselves twice, okay, in the same statement. So, with different values, and it just, it balloons out like a, fireworks display. I don't know. Okay, but booleans basically are 1 byte, by the way, and so are characters. They're 1 byte. But characters are typically signed. Booleans are not. It's really just a waste of 7 bits. And a float, that's typically, I don't know, I think a single float might just be 4 bits, 4 bytes, but I can't remember. And an integer is 4 bytes. Here, it should be 2 bytes, but traditionally it is. But they call that a short here in C. Now vector, is like a stack, and I'll get into that in a little bit. Jesus, I got a lot. This program you're looking at here, this Hello World Console .cpp, is actually a bully build. I think of the first, several chapters of that first book I went through on C. So, there's a lot of craziness in here I'm going to have to look at. I just wanted to get this, video made to test and see if you could hear me over the air conditioner.